L7.7 Part B. Now we just got done looking at using two functions and plugging a number into both. Each function would in turn change it to a different and new value. When we look at composite functions with coordinates, it's exactly doing the same thing, but with the work already being finished for us. So each function has done the work for us already. For example, if we look at g of x, what an ordered pair says is that a 7 was plugged in and the function changed it to a 0. Okay? In other words, if you plug a 7 in, you get a 0 out. Another way of looking at it is if you plug a 7 in for x, you get a 0 out for y, or g of x. If you plug a -1 in, you get a 7 out. Okay? Now what this is doing is it's telling you what was plugged in and it's telling you what came out without actually showing you the function. In the last example we did, we were given the next value, we did the work, plugged it into the function, and got our y out. So in comparison, this is less work. They've already done the work for us. So when we look at the type of question where it says f composite g, we're saying f of g of x. In other words, we're going to look at the g function first, because it goes right to left, and we're going to start with a 7. G function took a 7 and made it into a 0. And then we go to the f function and say if the f function started with a 0, it would change it into a -1. So for the composite, if you start with a 7 and go into the g of x function and then go into the f of x function, you'll end up with a -1. If you start with a -1 in the g of x function, it will change it to a 7. So if you take the 7 in the f of x function, that will change it to a 7, or keep it a 7 actually. So -1 from the g of x function ends up as a 7 in the f of x function, which is no change. If we start with a 4, the g of x changes it to a 9. The f of x function, the f function will take a 9 and change it into a 4. So starting with a 4, we'd end up with a 4. Stay the same. If you start with an 8 in the g of x function, the 8 becomes a 2. In the f of x function, a 2 becomes a 6. So starting out as an 8, going through two functions, you end up with a 6. And again, this is the g of x function, and this is the f of x function. Now if we switch directions, g composite f says to start with the f function and finish with the g function. In other words, it means g of f of x. So starting with the f function, a 2 becomes a 6, and a 6, there's nothing there. So a 6 gives you nothing in the g of x function. Therefore, for that point, it's undefined. So let's try a different one. A 9 gives you a 4 in the f function, and a 4 gives you a 9. So 9 ends in a 9. 7 gives you a 7. And a 7 gives you a 0. And a 0 gives you a negative 1. And a negative 1 gives you a 7. So 0 gives you a 7. And those are the composite functions with coordinates. Now with that done, I'm going to go to our last step, which is to come up with not a value, plugging into a value into a composite function. It's coming up with the composite function itself. So f of g of x means, or f composite g of x means f of g of x, which means f of, and g of x is this, which means we're going to plug that into the x values for f. So 3 times 2x minus 1 squared minus 2x minus 1 plus 4. That means 2x minus 1 times 2x minus 1 minus 2x minus 1 plus 4. So we have to FOIL to take care of that power. So we get 3 times 4x squared, outside is negative 2x, inside is negative 2x, and last is positive 1. I'm going to distribute this negative here, and we get negative 2x plus 1 plus 4. Now I'm going to distribute this 3 first. I could combine like terms right here, but I'll do that at the end. So we get 12x squared minus 6x minus 6x plus 1. Since I distributed the 3, I do not need to write parentheses anymore. Now it becomes one big adding like terms. So 12x squared, we have negative 6x minus 6x minus 2x. So that's 6, 12, 14, negative 14x. And then 1 and 4 is 5. So 12x squared minus 14x. Oops, forgot the 1 right here. So 4, 5, and 6. Oops, I forgot something. When I distributed the 3, I'll do this in red. When I distributed the 3, I get a positive 3. So now I have 3, 1, and 4. So to clean that up, I actually have a positive 8. So 12x squared minus 14x plus 8. Now that's a lot of work, but it was mainly because of the square. So let's try the next one. And that is g of f of x, which is g, or g composite f of x, which is g of f of x, okay, which is g of 3x squared minus x plus 4. So I will get 2 times 3x squared minus x plus 4 minus 1. If I distribute, I get 6x squared minus 2x plus 8 minus 1, which is 6x squared minus 2x plus 7. I did that real fast, but I'm running out of time. So that represents our composite function the other direction. And this ends 7.7 part B.